Chi-square goodness of fit test. Expected frequencies for a goodness of fit test. In a chi-square goodness of fit test, the expected frequency for each possible value of the variable is found by using the formula E equals N times P, where N is the sample size and P is the relative frequency or probability given for the value in the null hypothesis. Distribution of the chi-squared statistic for a goodness of fit test. For the chi-square goodness of fit test, the test statistic chi-square equals the sum of O minus E parentheses squared divided by E has approximately a chi-square distribution if the null hypothesis is true. The number of degrees of freedom is one less than the number of possible values of the variable under consideration. Chi-square goodness of fit test. Purpose: to perform a hypothesis test for the distribution of a variable. Assumptions: 1. All expected frequencies are 1 or greater. 2. At most 20% of the expected frequencies are less than 5. 3. Simple random sample. Chi-square goodness of fit test. Step 1. The null hypothesis and the alternative hypothesis are, respectively, H sub 0, the variable has the specified distribution. H sub a, the variable does not have the specified distribution. Step 2. Decide on the significance level alpha. Step 3. Compute the value of the test statistic. Chi-squared equals the sum of O minus E parentheses squared divided by E, where O and E represents observed and expected frequencies respectively. Denote the value of the test statistic is chi-squared sub 0. Chi-square goodness of fit test using critical values. Step 4. The critical value is chi-squared sub alpha with degrees of freedom equal to C minus 1, where C is the number of possible values for the variable. Use the chi-square distribution to find the critical value. Chi-squared sub alpha is our critical value. To the right of chi-squared sub alpha, the area alpha is the reject H sub 0 region. To the left of chi-squared sub alpha is the do not reject H sub 0 region. Step 5. If the value of the test statistic falls in the rejection region, reject H sub 0. Otherwise, do not reject H sub 0. Step 6. Interpret the results of the hypothesis test. Chi-square goodness of fit test using p-value approach. Step 4. The chi-square statistic has degrees of freedom equal to C minus 1, where C is the number of possible values for the variable. Use the chi-square distribution to estimate the p-value or obtain it exactly by using technology. The p-value is the area to the right of chi-squared sub 0, the test statistic. Step 5. If p is less than or equal to alpha, reject H sub 0. Otherwise, do not reject H sub 0. Step 6. Interpret the results of the hypothesis test. Example: the relative frequencies for the null hypothesis of a chi-square goodness of fit test and the sample size are given. Decide whether the two assumptions about expected frequencies for using that test are satisfied. Sample size n equals 125. Relative frequencies 0.49, 0.2, 0.3, 0.01. Assumptions: 1. All expected frequencies are 1 or greater. 2. At most 20% of the expected frequencies are less than 5. So we have the relative frequencies and the sample size. Starting with step 1, all expected frequencies are 1 or greater. We want to use the formula E equals N times P. So I start with my relative frequency of 0.49. E equals 125 times 0.49, and that's 61.25, which is 1 or greater. My next relative frequency is 0.2. E equals 125 times 0.2, which equals 25, which is also 1 or greater. Next, I'm going to use the relative frequency of 0.3. E equals 125 times 0.3, which is 37.5. This expected frequency is 1 or greater. Next, I'm going to use the relative frequency of 0.01. E equals 125 times 0.01, which is 1.25, which is also 1 or greater. Step 1 is yes. We can use the chi-square distribution. Step 2, at most 20% of the expected frequencies are less than 5. So we know our expected frequencies are 61.25, 25, 37.5, and 1.25. One of our expected frequencies is less than 5, so we need to make sure that that is at most 20% of my expected frequencies. I have 4 expected frequencies. One of them is less than 5, so that's 1 in 4, which is 0.25, or 25%, which is more than 20%. So no, at most 20% of the expected frequencies are not less than 5. The assumptions are not satisfied because more than 20% of the expected frequencies are less than 5, although the other assumption is satisfied. Example: the relative frequencies for the null hypothesis of a chi-square goodness of fit test and the sample size are given. Decide whether the two assumptions about expected frequencies for using that test are satisfied. For this example, the sample size n equals 200, relative frequencies 0.6, 0.35, 0.05. Again, our assumptions are 1. All expected frequencies are 1 or greater. 2. At most 20% of the expected frequencies are less than 5. Starting with 1, to find if our expected frequencies are 1 or greater, we need to use the formula E equals n times p. Starting with the relative frequency of 0.6, E equals 200 times 0.6, which is 120, which is 1 or greater. For 0.35, E equals 200 times 0.35, which is 70, which is also 1 or greater. For 0.05, E equals 200 times 0.05, which is 10, which is also 1 or greater. Yes, our first assumption is met. At most 20% of the expected frequencies are less than 5. None of my expected frequencies are smaller than 5, so 0% are less than 5. Yes, my second assumption is met. The assumptions are satisfied because the expected frequencies are all 1 or more and none are less than 5. Example using critical values. A distribution in the observed frequencies of the values of a variable from a simple random sample of the population are provided below. Use the chi-square goodness of fit test to decide at the specified significance level whether the distribution of the variable differs from the given distribution. Our distribution is 0.1875, 0.1875, 0.25, 0.375. Observed frequencies are 17, 20, 24, 35. Significance level 0.05. Step 1. Find h sub 0 and h sub a. For the chi-square goodness of fit test, h sub 0, the distribution of the variable is the same as the given distribution. H sub a, the distribution of the variable differs from the given distribution. Step 2. Decide on the significance level alpha. We are told that alpha is 0.05. Continuing, now we need to decide if all the expected frequencies are 1 or greater, E equals N times P. Our sample size is the total of our observed frequencies. So N equals 17 plus 20 plus 24 plus 35, which is 96. Starting with the first distribution, E equals 96 times 0.1875, which is 18. The second distribution is also 0.1875, so when I multiply that by 96, I get 18. My next distribution is 0.25. E equals 96 times 0.25, which is 24. My last distribution is 0.375. E equals 96 times 0.375 is 36. All of these values are 1 or greater, so yes, the first assumption is met. The second assumption, at most 20% of the expected frequencies are less than 5. Since none of the frequencies are less than 5, that's 0%, so yes, the second assumption is met. Step 3. Compute the value of the test statistic chi-squared. First, I need to know my degrees of freedom, which is C minus 1. I need to start with a table that has my distribution, which is P, my observed frequencies, O, and my expected frequency, E. The distribution and observed frequencies were given in the original problem, and we just found E by multiplying N times P. We have 4 possible values for the variable, so 4 minus 1 is 3. My degrees of freedom is 3. So now I want to find chi-squared. Going to our calculator, we want to go to Stat, Edit, and under L1 we want to type our observed frequencies O. 17, 20, 24, 35. Under L2, we want to type our expected frequency E. 18, 18, 24, 36. Now we want to go to Stat, over to Test, and we are looking for chi-squared goodness of fit test, GOF for short. Enter. Our observed values are in L1, our expected values are in L2. We calculated the degrees of freedom to be 3, and we want to calculate. Enter. So chi-square is 0.3056. So rounding to 3 decimal places, our critical value chi-square is 0.306. Identify the critical value. Step 4. The critical value is chi-squared sub alpha with degrees of freedom C minus 1, where C is the number of possible values for the variable. Use the chi-square distribution to find the critical value. Alpha is 0.05. Our critical value is going to be the value with an area of 0.05 to its right. We know that C is 4, which means our degrees of freedom are still 3. So going to our table, our degrees of freedom are 3, and our alpha is 0.05, and they cross at 7.815. So chi-squared sub alpha equals 7.815. Step 5. If the value of the test statistic falls in the rejection region, reject H sub 0. Otherwise, do not reject H sub 0. Our critical value is 7.815, and our test statistic is 0.306, which is in the do not reject H sub 0 region. Do not reject H sub 0, the null hypothesis. Step 6, interpret the results of the hypothesis test. There is not sufficient evidence to reject the null hypothesis. Example using p-values. A certain type of candy is reported to be distributed with color percentages shown in the table. The number of each color in a random bag of candy is also shown. Use the chi-square goodness of fit test to decide whether the color distribution differs from the reported distribution. Use alpha equals 0.05. Our color is our first row, percentage is our second row, and the frequency is the third row. For green, we have a percentage of 15 and a frequency of 21. Orange, percentage of 21, frequency of 25. Yellow, percentage of 14, frequency of 5. Blue, percentage of 24, frequency of 26. Red, percentage of 14, frequency of 14. Brown, percentage of 12, frequency of 7. Step 1. Find H sub 0 and H sub A. Since it's a chi-square goodness of fit test, H sub 0, the color distribution is the same as that reported. H sub A, the color distribution is different from that reported. Step 2. Decide on a significance level alpha. We were told that alpha is 0.05. Next, we need to decide if we can use the chi-square goodness of fit test. 1. All expected frequencies are 1 or greater, which is E times P. So in my table, I've changed my percentages from percents to decimals. So green is 0.15, orange is 0.21, yellow is 0.14, blue is 0.24, red is 0.14, brown is 0.12. I need to find N, which means I need to sum up the frequencies. Green is 21, orange is 25, yellow is 5, blue is 26, red is 14, brown is 7, for a total of 98. Now I'm ready to find the expected value. Going to my calculator, I'm going to type the percentage and the frequency observation in my table. Stat, edit. In L1, I'm going to put the percentage, 0.15, 0.21, 0.14, 0.24, 0.14, 0.12. Then I'm going to move to L2 and type the frequency, which is O, 21, 25, 5, 26, 14, 7. Now I want to find my expected frequency. So I'm going to arrow over to L3 and arrow up. We know that the total is 98. So 98 times my percentage, which is in L1, second, 1, enter. And then I'm going to move that information to my table. The expected frequency for green is 14.7, orange 20.58, yellow 13.72, blue 23.52, red 13.72, brown 11.76. All of these numbers are 1 or greater, so yes, we meet the first assumption. The second assumption is that at most 20% of the expected frequencies are less than 5. None of our expected frequencies are less than 5, which means we have 0%, so that's 0%. So yes, the second assumption is met. Step 3, compute the value of the test statistic chi-squared. First, we need to find our degrees of freedom, C minus 1. Since we have 6 colors, C is 6, 6 minus 1 is 5. Now we're ready to go to our calculator. Our O is in L2 and our E is in L3. Stat, over to test, and we want chi-squared goodness of fit test. Enter. Our observed value is in L2. Enter. Our expected value is in L3. Enter. Our degrees of freedom happen to be 5. And I'm ready to calculate. Enter. So my first value is my test statistic of chi-squared. I want to round that to 3 decimal places. Chi-squared equals 11.385. Step 4. The chi-squared statistic has degrees of freedom C minus 1, where C is the number of possible values for the variable. Use the chi-square distribution to estimate the p-value or obtain it exactly by using technology. Moving back to our calculator, we have a p-value of 0.044253. Rounding that to 3 decimal places, p equals 0.044. Step 5. If p is less than or equal to alpha, reject h sub 0. Otherwise, do not reject h sub 0. P is 0.004, alpha is 0.05. When we compare those, 0.004 is less than or equal to 0.05. The p-value is less than 0.05. Reject h sub 0, the null hypothesis. Step 6. Interpret the results of the hypothesis test. There is sufficient evidence to reject the null hypothesis. Recapping chi-square goodness of fit test. Expected frequencies for a goodness of fit test. To find the expected frequencies, we use the formula E equals N times P, where N is the sample size and P is the relative frequency for the given value in the null hypothesis. Distribution of the chi-squared statistic for a goodness of fit test. The test statistic is chi-square equal to the sum of the observed value minus the expected frequency, parentheses squared, divided by the expected frequency, where we have degrees of freedom of C minus 1, where C is the number of possible values for the variable.